Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
What's inside an egg? An average person eats around 173 eggs a year, and about 1.2 trillion eggs are produced worldwide. Eggs are a known source of protein for the immune system and muscle growth, and choline for the liver and for babies' brain development. Eggs are superfoods. Aside from the usual scrambles and omelets, eggs are used in soups, baked goods, pastas, meat dishes, and more. The most common egg for consumption comes from chickens, although eggs from ducks and quails are also consumed in different parts of the world. Let's take a look at the most popular egg choice, the chicken egg. Its basic shape is called a prolate spheroid, which means cylindrical with one end bigger than the other. The basic anatomy of an egg consists of 5 main components: the air cell, the eggshell, the membrane, the egg white, and the yolk. The air cell is found at the largest end of the egg. Air cells can help tell if eggs are fresh. Older eggs have bigger air cells due to air sucked through the pores of the egg over time. This is why rotten eggs float, because it has accumulated too much air inside its air cells. The eggshell is the hard protective cover of the egg, made up of calcium carbonate. Its color doesn't necessarily indicate the egg's quality or nutritional value. Eggshell color varies because of the various pigments deposited during egg formation. Usually, if the hen's earlobes or feathers are white, white eggs will be produced. If these are red, they will lay brown eggs. The shell membrane keeps the yolk and white of the egg together and protects it from bacteria. These are strong and made partially of keratin, a type of protein also found in human hair. The egg white, or the albumin, which cushions the yolk, is composed of 10% protein and 90% water. As food, egg whites are useful as binders for baking. And because these are high in collagen, a protein that promotes skin elasticity, egg whites are also used to make face masks. And finally, the egg's yellowish center, the yolk. It makes up 31% of the entire egg weight and contains plenty of vitamins and minerals. The color of the yolk is dependent on the hen's diet. Eggs from pasture-raised hens are said to have more omega-3 and less cholesterol, due to its consumption of natural feed.
another beautiful Tuesday afternoon. Welcome to the show. I am Tobi Lenkosi. I want to send tons and tons of love to Liberty. Thank you once again for standing behind us and sponsoring the show. Thank you so much for giving us a platform to help the class of 2021 and grade 12s. If you haven't done it yet, please do download the Tenfold education app. It is an app filled with tons and tons of past papers that could actually help you guys prepare for your final exam. Prelims are almost done and the finals are just around the corner. If you're wondering what questions we're doing and you'd like to fill in or join in the fun, please do send a hi on the WhatsApp number on the screen. Another platform where we're actually very active and alive is on YouTube, and there we are then Mindset Learn, and please do follow us there. So in today's show, we're going to be doing paper number 1 revision. Remember, you guys are only writing paper number 1 next week. So we're going to look at paper number 1. So I've got a few questions that I want us to move through. And again, today I'm going to show you how you analyze the question, what the examiner is looking for. Take your time and pace it out. And as you can see, as we keep moving, you'll see that most of the time it's more or less the same things that we've been doing. You just need to read your questions carefully and analyze accordingly. So the first topic that I have is from Tabiso. And he sent me a very interesting question about a drone. Right? This is a very interesting question. So this question says, in the diagram below, a drone with a mass of 5.8 kilograms is used to lift a mass. Now remember, if something is being lifted, it means it's moving in that direction. And if something needs to be lifted, I want you to really start thinking about it in your head. Think about vectors. If something needs to be lifted, we need to have an applied force. So it's used to lift a mass of 3.2. So I could already see that something is attached to the drone by using an inextendable cable. This just means that the length of the cable remains the same. It means that as this drone is lifting it up, it doesn't go shorter and longer like a spring, so it remains the same length throughout. Inextendable cable of negligible mass, so this means the mass is so tiny and so little that it really has no effect in the whole question. The tension, now we know, when you see the word rope, my darlings, you know that there is tension. The tension of the cable is T, and the drone accelerates. Now, I want you to already think. It accelerates vertically upwards. So we were right, as we have an arrow here. Remember, anything accelerates, Newton's second law. It means that F net is equal to ma. I must already put that in my mind because there is acceleration. And if there's acceleration, it means there's a change in velocity. Upwards, add 0.9 meters per second squared. The lifting force of the drone is 100 newtons. So remember what we said, there is an applied force that the drone now has. So the lifting force, the force of lifting is 100 newtons that the drone has. The frictional force, okay, so now we also see that there's frictional force. Now I just want to elaborate on this one quickly. So most of the time when we do Newton's laws, now we know most of the questions will have a force on a frictional surface, something going up an incline, because we know that the coefficient is the ratio of the surface in which something is moving. But in this case, something that is in the air, they're talking about frictional force, so it must be air friction. So the frictional force, which is F, experienced by the drone and the mass as they move upwards, is therefore then the same. So they both experience the frictional force of the drone and the mass. So this is technically how it looks. I'm just going to grab this box here. So now here we have a drone. This is my drone. And we've got a string here. And as it's moving with the mass. So whatever acceleration that the drone is moving up with, the mass is experiencing. And remember, they are in the same air, right? In the same vacuum. So as the drone is moving up, if there's air that's going to come and shift it away, the mass is going to move exactly the same. So whatever frictional force the drone is experiencing, the mass will also therefore experience. It's very crucial that you understand this concept before we start answering the questions. So here's my drone and there's my structure. Just remember that it is moving upwards. Remember, if the drone is moving upwards, the mass will follow. They did say that the frictional force of this drone and the mass is therefore the same. Here's our acceleration. So now let's see what questions do we have here. So the first one is state Newton's second law of motion in words. Now remember guys, you cannot fail definitions because you are lazy to learn. If you can think about it, every single time we answer a question, there is a definition that needs to be answered, and it's for 2 marks. So if we counted all the 2 marks, you can actually come up with 20 or 30 questions. So you cannot fail because you're lazy to read. So with Newton's second law of motion, it says when a resultant or net force acts on an object, the object will accelerate in the direction of the net force. the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Like I always say, I always think of it as a formula. Remember, when the net force acts on an object, it will accelerate in the direction of the net force is equal to ma. F net is directly proportional to ma. The second part of my sentence is acceleration is directly proportional. Now I know that they've made acceleration the subject of the formula, which means is A is equal to F net over m. Then I therefore say acceleration is directly proportional to the net force and inversely proportional to the mass. Like I always say, if you know your formula, then you are able to answer any definition. So always use your formulas. That's how I actually got through to grade 12. So the next question, it says we must draw a fully labeled free body diagram for the mass. So now, fully labeled, meaning you have to show your vectors by your arrows. You have to also name them. A free body diagram, there's a difference between a vector diagram and a free body diagram. Free body diagram, the object in question becomes a circle. Vector diagram, we use a block. So now I just want to go back. So they're looking for mass M. So I want us to look at the drawing that we have here. So I know that M is being pulled up, so I can already see that, oh, we'll have tension in this direction. The last statement is very important. It says the frictional force that the drone and the mass will experience moving upwards is the same. Remember, when you talk frictional force, it's always away from the object. So that will be my force of friction. But also remember, anything that is hanging, gravity says, come back down. And we also have gravity moving downwards. Another thing to remember, if you have to draw free body diagrams, you have to look at the mark allocation. 3 marks means 3 forces. So free body diagram, it becomes a circle. Now I know there is a string that's attached to the drone. This is the tension or the force of tension. Moving downwards is the frictional force because there's wind that's moving all around. So I can write a frictional force that it's experiencing, also moving in the same direction, is Fg, which is the force of gravity. 3 marks, 3 forces. Free body diagram means we use a circle and not a block. That's then a vector diagram. Most of the time, vector diagrams are used in grade 11, but you see them now and again. Then we've got question 2.2. It says we must calculate the magnitude of the frictional force experienced by the drone and M. Remember what the last statement said, that the frictional force that the drone and mass M will experience is exactly the same. Now here we've got 7 marks. Now already they're talking about 2 objects in question. We've got the drone on one side and then we've got the mass on the other side. We know that the friction is exactly the same. However, we don't know what the tension is. So we already have tension and we already have friction that's also unknown, meaning we're going to have a simultaneous equation. Now when we get to questions like this is exactly the same as 2 pulleys moving up a ramp or 2 blocks sliding down a ramp, and you have to do that simultaneous equation. How I teach my kids, always draw a free body diagram for both. Once you have the free body diagram, you are then able to see which one must be a positive, which one needs to be a negative, and so forth. Remember, if you're doing a simultaneous equation, then the tension, most of the time, the tension needs to cancel. So this is how we're going to do it. I'm going to elaborate it for you so that you can see exactly what's happening. So I'm first going to do the drone, and I'm going to write all the information for the drone. And then I'm going to do for mass M. Remember, it is a simultaneous equation, but I'm going to first find my equations. So I want to just draw everything for the drone. Remember, the drone is moving upwards. They did say that it has a lifting force. So this is the force of lifting, or you can write lifting force, but it's always nice to just write force of something. So now remember, there is a string that is attached to mass M, which means there's tension in that string that the drone is experiencing while it moves up. Moving down, they did say that the drone and the mass experiences the force of friction or a frictional force, and we know that the frictional force is therefore the same. Also moving down, remember the drone is moving somewhere up there, which means this is a force of gravity or gravitational force. So these are all the forces that are acting on this drone. Remember, as you have this drone, as it's moving up, it is moving up, so there's a force that's making it move, right? They also did tell us that it's accelerating, and then they also asked us for Newton's second law. So I already know that there's F net. So as it's moving, frictional force says, come down, gravity says, come down, and there's tension in the string where this mass M is also moving. So if all those 3 forces moving in the same direction, and only the force of lifting moving in one direction, as you can see here. Just want to redraw this one again with mass M. I have my tension moving up. I can already see that tension is moving up in this direction, but tension is moving down in this direction. Vectors in opposite directions, we can therefore subtract. But with the drone, I had two forces that are acting in the opposite direction. I had the force of friction, or the frictional force, and then I had Fg. And as you can see, I can see that my frictional force for my mass and my frictional force for my drone is exactly in the same direction. So now let's find my equation. I'm not done. So I'm going to find an equation for my drone as well as for my mass, and then I'm going to solve. I'm going to start with the drone first. So always we're going to have F net, because that shows that the resultant of all these forces. So what forces do we have? So in this case, it's F net is equal to ma. They did say it is accelerating. Now let's look at net. Remember, net means the total forces acting on it. We've got FL, which is the lifting force moving upwards. Vectors in opposite directions, we subtract. Minus tension in the opposite direction, minus the force of friction in the opposite direction, minus Fg in the opposite direction, all equal to ma. We are told that the drone has a lifting force of 180 newtons, minus, I don't have the tension, I don't have the frictional force. That's what we need to calculate. And I know, remember with Fg, I just want to write this and elaborate it. Fg is equal to mg, which is the mass times gravitational acceleration. So I'm just going to plug it in as it is. The mass of the drone is 5,8. Gravitational acceleration is a constant, which is 9,8, all equal to mass is again 5,8. They did tell us that the drone is accelerating. There's a difference between the G for gravitational acceleration and A, which is accelerating. I just want to go back to the statement and show you here. They did tell us, there we are, that the drone accelerates vertically at 0,9. The 9.8 is gravitational acceleration. Don't mix the two up. So the acceleration that I have for the drone is therefore then 0,9. Now I can simplify my diagram a little bit. So I'm going to add these to simplify. So in this case, I've got 180, oopsie daisy. I've got 180 minus, I'm going to open a bracket. It's 5.8 times 9.8, 5,8 times 9.8. And I'm going to get an answer here. 123,16. So I have 123,16. I still have minus tension minus the force of friction equal to, I'm going to work out that. In this side, I get 5.8 multiplied by the acceleration of the drone, which is 0,9. And therefore, I get 5,22. I get 5,22. So now I'm going to just make tension the subject of the formula. So you can do it in various ways. I'm just going to make tension the subject of the formula because I know it needs to cancel. Why do I need to cancel? Tension is going down in this direction, but up in this direction. If you add the two equations, a negative plus a positive will give you 0. So tension will then therefore cancel. So I'm just going to make T the subject of the formula. I'm going to leave it as a negative T on this side. I'm going to let this number jump. Let me do it the long way around. I'm going to have minus force of friction. I'm going to have plus 5,22, and I'm going to have minus 123,16. Let me just put that in my calculator now. So I've got 5.22 minus 123.16. I'm going to get an answer there. So here I get 17, let me just double check that. Let me just see if I did that right. No, I said 23. 5.22 minus 123, backspace, 123,16. There we are. Back on track. Now I get 117,94. So I still have the force of friction, and I get negative 117,94. 117,94, and that is my minus my tension. Oh, now that's only for the drone. This will then be question number 1, equation number 1. And therefore, I'm now going to do the same, but only for mass M. Again, I just want to write it in a different color, which gives me F net is equal to MA. Now with the drone, I only have these two moving downwards and tension moving upwards. So F net is made by my tension in one direction, vectors in opposite directions I need to subtract, minus my force of friction minus Fg is all equal to Ma. Now, remember, I don't know what my tension is. I also don't know what my force of friction is, but I need to calculate it. Fg, I'm going to use exactly the same. Fg is equal to mg, the mass times gravitational acceleration. Please do not mix that up. Remember, they told us that the drone has a mass of 3.2. Gravitational acceleration is 9,8 equal. The mass of the drone is 3.2. They did say that the drone is accelerating upwards, meaning wherever the drone is going, the mass is going. And it's an acceleration of 0,9. And I'm going to do exactly the same thing on this side as what I did on the other side. So with this one, I get 3.2 multiplied by 9.8. So I get 31.36. So I'm going to have tension minus my force of friction minus 31.36. 31.36. Let me work out that side. On this side, I've got 3.2 multiplied by 0.9. And then I get 2.88. 2.88. Again, I'm going to make tension the subject of the formula because tensions are now going to cancel. You can see one is positive, one is a negative. So I'm just going to leave my tension on this side equal to, I've got the force of friction in this direction, on this side, plus I've got 2.88. This jumps over, it becomes a positive 31.36. I'm going to have tension is equal to my force of friction. I'm just going to add this side. So I've got 2.88 plus 31.36, which will give me 34.24. Plus 24, 34.24, other way around. Just erase that. So this is 34.24. And this is now equation number 2. Whew. So now we are only halfway there. Now that I've got my 2 equations, I can now equate. So different teachers do it differently. Some teachers say you equate the 2 equations. Some teachers say you subtract. Some teachers say you add. I just actually add both the 2. For me, it's a little bit easier. But if your teacher's showing you something different, you're more than welcome to use that one. So let me just use another color here. So now we can all see what Tobile is doing here. So I've got equation 1 as well as equation 2. So I'm going to add the 2 together. I've got this equation here first. So I've got negative tension is equal to minus FF minus 117,94 plus, I'm just going to put my equation sign there. I've got tension. I've got F of F. This will give me a positive 34.24. I just want to double check something here. Remember, force of friction jumps the equation sign. This becomes a positive, yes. So I'll have a positive on this side. That looks perfect. I'm just going to add the 2. A negative plus a positive, so tension will therefore cancel. I've got force of friction plus another force of friction. Now, this is where our mathematics comes in. Remember, we've got like terms. It's like me saying x plus x is 2x. Don't see the 2 frictions and start freaking out. I've got 1 frictional force here plus another frictional force here. So which means that gives me 2 frictional forces. It's exactly like that. And I'm going to add these 2. See what we're going to have here. So if I say negative 117.94, and I must add 34.24. Therefore, I get 83.7. I'm going to have, let me just see if it's a positive or a negative. That's negative. Negative 83.7. Now I'm going to take this one to the other side, becomes a negative. Let me just do it the long way around. This becomes 2f of f. Remember, if a number jumps the equation sign, the sign changes. This becomes negative 83.7. Must make both a positive, divide both sides by negative 1. The negatives will cancel. So I'm left with 2 frictional force is equal to 83.7. They're not looking for 2 frictional forces, they're just looking for 1. So I divide both sides by the 2, so I can get the force of friction by itself. So 2 and 2 will cancel. I'm going to take this answer that I have. I'm just going to do it exactly as it is. So I get 41.85. Remember, it is a positive, so I can just say the force of friction that is experienced by the mass and the drone will they give me 4185. That will give me 41,85. Remember, the SI unit for friction is therefore then a capital letter N. And that isn't how I would have done it. Step number 1, it is for 7 marks. It is a simultaneous equation. There were 2 unknowns. We don't have friction, we don't have frictional force. How I always teach my kids, start with a vector diagram. It's very important you know how to draw a perfect vector diagram. And I can already see F net will be this one in its own direction, vectors in opposite directions, we subtract. Exactly the same on this one. Tension needs to cancel because one tension is a positive, one tension is a negative. Just to add on, you cannot have the force of friction cancel because it's moving in the same direction, right? And I know that there's 2 of them since the drone and the mass both experience it. So I cancel out my tension, looking at the green part over here. And remember, if one frictional force plus another frictional force gives me 2. They're not looking for 2 frictional forces, only for 1. So I had to divide both sides by 2. And that isn't how I get my force of friction, which is easy peasy. Now, this is definitely one of the best follow-up questions that they love when they say, calculate the tension in the string. This is now for 2 marks. Now, just to add on to something. So if you spend time on this question and you felt like, oh my word, Torps, I'm still not sure if this answer is correct, please use the frictional force that you got in your answer and plug it in here. Best believe that you'll actually get credited for using, even though it's the wrong answer, but for using it in the right place. And you show the examiner, I might have made a mistake somewhere here or there, but I do know that this frictional force can be used in this equation. So now you can choose which equation you want to use. We've come up with equation number 1, which is the mustard color, and then the blue color. So I'm going to just take the blue color. Either or, you'll both still get exactly the same answer. So remember, we've got tension is equal to the force of friction plus 34,24. And then I'm looking for the tension. My frictional force that I got was 41.85. 41,85. I'm going to add this to the 34.24. And you get exactly the same. Sometimes the questions are very specific to say, calculate the tension that the drone will experience. Then you use the formula of the drone. But in this case, they're not very specific, so you can choose either one. You should get the same answer for both of them. This will give you 76,09. Always remember to leave your answer to 2 decimal places. Don't just write 76. 76,09. SI unit for tension is again, therefore, then a capital letter number N. If we did it for this equation, we would get exactly the same thing. And this is then, I think, the last question that we have for this question, with the drone question. Yes, this is our last question. It's a very interesting question, but how I always like working with questions like this, think of it in your mind and see the drone actually moving and think about in which direction the force is moving and in which direction will the air swing and all that stuff. And it actually makes perfect sense. But this is a fabulous question. Nonetheless, I will see you after the ad break and we'll be doing more revision on paper number 1.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just 1 too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human. Because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Welcome back from the ad break. Thank you so much for still staying tuned. You're still staying with me, Utobile. I want to send tons and tons of love once again to Liberty. Thank you so much for the platform. Thank you so much for the support. We've been going at it all for the class of 2021. And grade 12s, if you haven't done it yet, please do download the Tenfold education app if you haven't done it yet. It is really, really an app filled with tons and tons of past papers. I can see some of you guys are getting these questions from there when you send your screenshots. It is really, really very helpful. And if you're wondering what questions we're doing on today's show and you'd like to join in, please do send a hi on the WhatsApp number on the screen and meet our friend Dex. And another platform where we're actually alive and funky and actually very available is then on YouTube. Please do follow us there because then we are a Mindset Learn. So right before the ad break, we did a topic or a question on paper number 1, which was all about a drone and Newton's laws. Now we're moving into another topic, also in question number 1. And I know most of you guys get a bit confused when we do this question. Just want to see who this question is for. Ndotana, thank you so much for that question. But it is vertical projectile motion. Now, my darlings, if you haven't had an imagination by now in physics with this topic, you really have to imagine. It's all about how you think or your conceptual thinking, but also you need to become an artist. You really need to draw. And I'm going to show you guys how you actually analyze a vertical projectile motion question and how you can actually answer any vertical projectile motion question. It's most of the time 2 things happening at once. One must be going in whatever direction. So it's all about vectors, it's all about directions and choosing the correct formula. So let's see what this question actually says, because I can already see what the diagram is saying. So it says a ball is thrown vertically upwards. Now we know that if something is thrown, then there is an initial velocity. That's the first thing. If something is thrown, if something is pushed, if something is pulled and all that, there is then an initial velocity. But if something is released, if something falls, if something is dropped, then there is no initial velocity. It's almost like it was an accident. But in this case, it was thrown, so we do know that there is initial velocity upwards, and it was a height of h with a speed of 15 meters per second. At the same instant, meaning the time is exactly the same when this happened, a second ball B is dropped. Now, dun, 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 dun. If something is dropped, then there is no initial velocity. It's dropped from the same height as A, as shown in the diagram. Both balls undergo free fall. So it's only gravity and eventually hit the ground. So let's look at our diagram over here. So I can see that A goes first up, and then it comes all the way down, whereas B starts from here and then it falls down. The initial velocity of A is 15, meaning that the initial velocity of B will be 0 meters per second. Why am I saying this? Remember, B was dropped at a certain height. Now, I just want to also add on to something here. Remember, when A is thrown and it reaches its maximum height, which will be its final velocity at maximum height, final velocity is 0 meters per second. This means that you don't really see it with the naked eye, right? But if you throw a tennis ball up and it goes all the way, at some point, it goes still for a little minute and then it starts going down. But it happens so quickly that the naked eye cannot see it. But in actual fact, in physics, we do actually pick it up and say that the final velocity will therefore then be 0 before it comes down. So let's see what questions we have. So 3.1 says, I must explain the term free fall, and that is for 2 marks. And remember, definitions, we don't fail, my darlings. So free fall, an object moving or which is moving under the influence of gravitational force. You can add on to say there are no other forces. There are no other forces such as friction. So there's no other forces acting on the object such as friction. So that is for 2 marks. And then 3.2 says, I must calculate the time it takes for ball A to return to its starting point. Now I need to choose direction. So I can see in this part here that A will move all the way up and it comes back down. So this question says, if this is A, for A to come back to its starting point, we'll draw that there, how long will it take? Now, according to physics, we know that time up is equal to time down, especially because I don't know how high A went. And I'm going to have a lot of unknowns if I'm going to move in that dimension. But now I don't know how high A went, but I know that time up is equal to time down only in the opposite direction. So that's one way of thinking it. So let's see. Let's calculate the time it takes for A to return to its starting point. So the first way that you could have done it was only for 4 marks. So I could have said VF is equal to VI plus A delta T. So now I can see here that I need to choose direction. So I think for this one, it depends on you, but I'm going to take up as a positive and I'll take down as a negative. So any vector moving up will be a positive and all the others then moving in the opposite direction will therefore be a negative. Just rewrite it here so we also remember. It's also nice to show your examiner that this is the direction that you have actually chosen. Remember, final velocity at maximum height. We don't see it, but in a split second, it actually comes to a complete stop. So that will then be 0. We are told that it was thrown with an initial velocity of 15. Initial is moving up, so I keep that as a 15 plus. Gravitational acceleration is moving down. It's always moving down. 9.8, and the question does want the time. So this is a negative. I'm just going to take it to this side of my equation sign, which will be delta T is equal to 15. If any number jumps the equation sign, it becomes a positive. I want delta T by itself. I'm going to divide both sides by 9.8. That looks like an 8. There we are, 9.8. 9.8 and 9.8 will cancel, leaving delta T on this side. So let's see what my time will be here. So this will be 15 all over 9.8. So I get 1.35. So the time is 1.35 seconds. But as you can see, this is only to maximum height. So this means, let's become an artist again. So for this object to move from here going up, it took a time of 1.53. We know in physics time up is equal to time down. So it means the time going down is another 1.53 seconds. So it means I can take my original answer, which I found here, and I'm just going to multiply it by 2 because they do say to return to its starting point. So it means I must multiply that by 2. So I'm going to take this answer, multiply it by 2, and I get 3.06. So my time for A to return to its starting point will be 3.06 seconds. That's one way of doing it. Another way that you could have actually looked at it, if you had this line of thinking, it's not wrong to have that line of thinking because there's people who think differently. So you could have said, how high did A go? Once you found how high did A go, then you are able to therefore calculate how long did it take A to reach that maximum height or to reach that height. So remember, it's all about time. So you could have first found your height, and after finding your height, you could have then therefore found the time. Remember, with questions like this, it's a little bit tricky because if your height is wrong or if you make some mistake there where it's wrong, then moving forward, you can be a bit wrong. Well, you will get credited where it needs to be credited, but how I always say, always use the information that you are given and try to solve. If there is really no way out, then find something and then plug it in. So with this one, let's see if you really wanted to find the height first, then you could have done it in this direction. Let's first find how high did it actually move. So remember with height, I'm going to use delta y because it's on the vertical axis. So I could have said VF squared is equal to VI squared plus 2A delta y. Initial velocity, I'm still taking up as a positive, is 15 squared. My final velocity is 0 at maximum height. I'm going to say plus 2. Gravitational acceleration is minus 9.8. I'm first going to find, this is a y, there we are. I must first find my delta y before I can find my time. I'm going to do exactly the same thing. Let's just multiply this first so that it makes it a little bit easier for us. So this is 15 squared, 225, I'm going to remember that, 2 times 9.8, which will give me 19.6. So with this one, I got 225 minus 19.6 delta y. I'm going to take this to the other side. If any number jumps the equation sign, the sign will change. And this becomes 225. I want delta y, divide both sides by 19.6. 19.6, this and this will cancel. So delta y should give me the height at which it traveled. So this is 225 divided by 19.6, which gives me 1148. I'm just going to leave it to 2 decimal places, 1148.48 meters. So now I've got that height. Now we're still looking for time. So just going to move over here and I'm going to work up here. Now I can use the height that I found. Remember, we have final velocity plus initial velocity all over 2 and delta t. I am looking for the time. I do know that it traveled a height of 1148. Remember that my final velocity was 0. Initial velocity was 15. Will be a positive 15 all over a 2. And I am looking for time. So I'm just going to work that out in my calculator. So I'm going to just say 15 over 2, or 15 divided by 2, will give me 7.5. So I've got 1148. Ooh, okay. We had a bit of a Wacom jam there. 48 is equal to 7.5, if I'm not lying. Yes, 7.5. And that is all delta t. I'm looking for delta t by itself. Divide both sides by 7.5. What you do on the one side, you do on the other side. This and this will cancel. Let's see if we get the same time. So I'm going to say 11.48 divided by 7.5. There I get 1.53. So I get 1.53 seconds. Remember, that is time going up. Multiply that by 2. It's exactly the same as this step over here. So I get 3.06 seconds. So that's one way of doing it. As you can see, the blue method is still correct and it's fine, but a little bit longer. And then the other color, which is like the mustard color, is a little bit shorter and you get exactly the same marks for exactly the same steps for exactly the same marks. So then it just depends on you. But remember, the way you think of how to do the question is not wrong. That's the nice thing about physics. There's millions of ways to actually solve one equation. So let's go on to the next question. So the next one says we must calculate the distance between ball A and ball B when A is at its maximum height. Now you're going to stand, dun, dun, dun. Oh my word, tops. Next question. No, not to the next question. I just want to erase this quickly and I'm going to show you how or what the question is actually asking us. So they want to know if we have ball number A here, ball A goes all the way to its maximum height. When ball A is over here with a final velocity of 0 meters per second at maximum height, and remember, at the same instant when A was thrown up, B was thrown down. So now we've got B that was also thrown down, starting from there, and B is wherever height it is. What is the distance between the two? So we're looking for the distance of A as well as the distance of B. And we're going to add, let me just write delta y1, that's the first distance, and delta y2, which is the second distance. And then we can add the distances. Now, I want you to think logically. Here's our experiment. I've got ball A and ball B. Simultaneously, one is thrown up and one is thrown down. So here we go. Ooh, we know when A is at its maximum height, that was a time of 1.53, right? And whatever A was at its maximum height, from the original height where B was traveling, it would have moved a certain distance moving down. So this is my logical thinking. If I am able to find, one, the time that it took A to move to its maximum height, that will be the same time that it took B to be at whatever height. That's the first thing. Then I need to find out, okay, when A was at its maximum height, what was the height there? Okay, in the previous question we've already calculated, but then I've got the height there. Then I need to find out if B took 1.53 seconds to move there, wherever it was, A was on its maximum height, then I can add the two equations. Because remember, it's happening simultaneously. If we know the time it took A to reach to its maximum height, then we know how long it took B to be at that same height. So this means it took A a time of 1.53 seconds to reach its maximum height, to be all the way up there. So B also started at the clock of 0. It took B, or it's going to take B, the same time. Remember, this happens simultaneously. It takes B 1.53 seconds to reach that destination, or that height over there. So this is how I'm going to tackle this question. I've got two things happening at the same time, and I need to calculate it. So I must calculate the distance with A and B when A is at its maximum height, and this is for 7 marks. So let's start with ball A. So with ball A, so now depending on how you've actually done it before, so just for the argument or just to save time, I just want to work on this one. So with the same equation, I'm going to work until I find the distance that A takes to reach its maximum height as 11.48 meters. Remember what I did? I used the initial velocity that it was thrown up with, final velocity was 0, and then I found out that for A to reach its maximum height at that initial velocity was 11.48. So if you didn't calculate it, you'll have to calculate it over here. So this will then therefore be the distance for ball A, which is 11.48 meters, which we've calculated in the previous question. Now we need to calculate for ball number B. So really we have the time that can actually guide us. So let's find the distance. So I know that delta y, remember I'm finding a formula. Let me just put a B there so the examiner can see that this is for ball B. So I'm going to take initial velocity, I'm going to say change in time plus 1/2 A delta t squared. Now I'm using a formula that I am comfortable, or I can see what I actually have. Just want to show you with this one quickly why I'm not using this formula for ball number B. I don't know what the final velocity of ball B was. They didn't say that it reached the ground, so I don't know what the final velocity is. I do know the time, initial velocity is 0, but I've got so many unknowns, and this one I cannot use because I'm actually looking for the distance, as well as this one. I don't know what the final velocity is. I don't know what delta y is. Cannot use it. Same thing. Okay, this one as well. I don't know what my final velocity is. So as you can see, this equation here is more comfortable for me to use. Why? Because I know that this ball was dropped, meaning that the initial velocity was 0. Remember, we're working on the time of ball A to reach maximum height. They did say when A was at its maximum height, that was a time of 1.53. Please don't use 3.6 something, 3.06. That was for A to move here, go do, and reach all the way here. That was for A to, from the starting point, coming back to the starting point. To reach maximum height is half of that. Plus, I'm going to say 1/2 gravitational acceleration. Remember, I am taking up as a positive and I'm taking down as a negative. Gravitational acceleration will be negative 9.8, and this will be my time, which is 1.53 squared. This one should then therefore be a little bit easier. Anything multiplied by 0 is 0 plus. I'm going to put everything exactly as it is on my calculator. Just move this one over here. I love putting everything in brackets. It just makes it much more easier. I've got 9.8. I've got 1.53. I'm not going to put the negative because I can already see that A is going down, and I've taken down as a negative. You can put in your calculator if you want. It's not necessary though. Squared will give me 11.47. So I know that this, let me do it the long way around. This will be negative 11.47. So this will give me negative 11.47. Remember, displacement or delta y will be a vector. Negative just means it's moving downwards. So I can remove the negative and write meters. Now, let's see. This is 11.48 and 11.47. I just want to go back to my original diagram. Let's see what we've added. So I want to work in green now. So for A to move from its starting position to maximum height took a time of 1,53 seconds, and it reached a height of 11,48 meters. In the same time, it took B from its starting point when it was released all the way to this height over here. It also took it 1,53 because remember, when A was at its maximum point, B had moved exactly the same time, meaning that delta YB of ball B had actually moved a distance of 11,47. Now, they do want the distance between the two. They didn't say difference or anything, so we must just add the two distances. So I'm going to make it look fancy, showing the examiner what I'm doing. I'm going to say distance total. So remember, it is that of A plus the distance of B between them. A was 11,48 plus B, which was 11,47. This one was fairly easy. Now we just have to add the two. So I've got 11.48 plus 11.47. Always leave your answer to 2 decimal places. This one is already here. It's 22.95. And this will give me 22,95. SI unit for distance is therefore then a small letter M. So I've got my distance between the two. So I think the important thing to remember with this one was to remember if they want the distance between the two when A was at its maximum height, is that the fact that they would have traveled the same time. So we have to use the time for A that we got to reach maximum height for the same for B and see how far B had fallen at the same time that A took to reach maximum height. There's a number of questions that use exactly the same principle. And as you can see, I keep going back to my diagram and drawing using different colors and actually using it and saying it in my head so that I actually know exactly what is going on. So let's look at our next question. So the next question says, sketch a velocity time graph. Guys, you cannot fail a graph. Again, with graphs, even if you got the wrong initial velocity or final velocity or distance or whatever, use it correctly in the graph. Show the examiner that even though you might have made a little bit of a mistake there, but you know exactly where it's going on the graph. And another thing, my darlings, use a sharp pencil and a ruler. You cannot draw a drawing in freehand. It doesn't work like that. Please use a sharp pencil and use a ruler when you draw your diagrams. It just makes it a little bit neater and it makes it a little bit easier for the examiner to actually mark. You don't want the examiner to be sitting there using a magnifying glass to actually see what's going on, right? Make sure that your work is neat and very readable. So with this one, we must sketch a velocity time graph. They love a velocity time graph in the answer book for the motion of ball A. So remember, ball A is what we actually threw up from the time it is projected until it hits the ground. We must clearly show the following on the graph. The initial velocity, reading the statement that we were given, the initial velocity, remember it was thrown upwards with an initial velocity of 15 meters per second. The time it takes to reach maximum height, we did calculate this one. The question asked for the time to reach starting position, but maximum height was 1,53 seconds. If you think this answer is wrong in your previous questions, just use the correct answer in the same place. The time it takes to return to its starting point, which was double of that, which means it was 3,06 seconds. So now let's answer. Now, remember, when you're drawing a graph, it's always nice to just label your graph and give it a heading. We are doing a velocity time graph. Velocity versus time. So now I'm going to do two depending on how or what you took as your direction. In this case, I'm going to take up as a positive and down as a negative. Initial velocity, remember it started at 15. This was 15. Okay, let me just do this, otherwise I won't have space. Let me just write a bit skew. So this is my velocity. Remember, velocity is in meters per second. And then this is my time. Let me use a different color. So, okay, this is then 15. This one will be 0. And then remember, the time it reaches maximum height, this is my time. So I can say somewhere there, it doesn't have to be drawn to scale, but just indicate accordingly. So I can move all the way down here, moving all the way down. Now remember, the time it takes to reach its starting point is double of this one. So it means if I'm stopping here, this means this is when it reached its maximum height. Let me just make space for me to write. which was 3,06 seconds. And there we are. And remember, I just want to elongate this one a little bit longer. So remember, velocity up is equal to velocity down. So I can also say, okay, mine's not really drawn to scale, but it should be touching somewhere there. This will be negative 15 velocity. So if the velocity to throw the ball was 15 going up, it's exactly the same velocity going down in the opposite direction. So that's why I've got a negative 15. They didn't want the time it takes to reach its starting point. But let's say, my darlings, you took the direction as the other way around. So for example, if you took up as a negative and you took down as a positive, working exactly the same way, I'm going to name this velocity. Velocity is measured in meters per second. And then I'm going to have time in this direction. But now it kind of works the other way around. It's exactly the same. It all depends on your direction. So in this case, I've taken up as a negative. It must be in the negative quadrant. Remember, there's a 0 there. So this is negative 15. So mine starts there, moves all the way up. So I'm just elongate it there, which means at this place, remember, where my velocity is 0, it took a time of 1.53. That was maximum height. Then I can therefore say, the time it took to reach its starting point was 3,06. And then I can also say velocity up is velocity down if an object returns to its starting point, which will also then be 15 meters per second. And that is then what I would have done to answer this question. Now, there's various ones that they could have shown you. This one was for 4 marks. I always say, read your question accordingly and try to analyze it as much as you possibly can. So I just want us to read through this one again. I know velocity time graphs or vertical projectile motions might be there for a little bit different. Let's use a sketch. So with the sketch that we were given, let me just erase all of this. Just use a big one. So with A, they did say A started off here. They did want us to calculate or draw the graph all the way when it gets back to this information here. I do know that my final velocity here would have been 0. Remember, velocity up is equal to velocity down, only in opposite directions. Vectors in opposite directions, one needs to be a positive, one needs to be a negative. I had taken up as a positive and then down as a negative. So that is technically what they were looking for, because we didn't really know whether it hits the ground or it bounces up or however. But if you know this, you can answer any problem. Let's see if we can squeeze in another question. So with this one here, it's question number 5. And I can see that it's also forces, and I see conservative forces and all that stuff. So the question says a 5-kilogram block is released from rest. Now remember, anything is released, anything is dropped, then the initial velocity is therefore then 0. So from rest, again, I can see that initial velocity is 0 at a height of 5 meters and slides down a frictionless point. So there's no friction. Frictionless incline to point P. So it starts off here with its initial velocity as 0 meters per second, and it slides down all the way to number P as shown in the diagram below. It then moves along a frictionless horizontal portion, which is PQ, so still no friction between this part, and finally moves up a second rough. The minute they say rough, uneven, and all of that, we do know that there's therefore then friction between these 2 points over here. It comes to a stop at R, which is 3 meters above. Remember, if something comes to a stop, then it means that the final velocity of that object will be 0 meters per second. So let's see. Now the question says the frictional force, which is a non-conservative force between the surface and the block, is 18 newtons. So now 5.1 says, using energy principles only, calculate the speed of the block at point P. Now I just want to see here. Remember, it starts off here, it slides all the way down. We must calculate the speed here. Now remember, energy principles, it currently has potential energy. It starts moving, now it has kinetic energy. Those are my energy principles. Not very difficult, it's only for 4 marks. So I can say a change in EP plus a change in EK is equal to 0. Remember, EP will therefore then be mghi plus mghf. Kinetic energy, let me just put this under one bracket, will be a half mv squared I plus a half mvf squared is equal to 0. So I'm just going to plug in. Initially, it had a height. The mass was 5. Gravitational acceleration was 9,8. And then the height was 5 meters. Remember, on the ground, there's no potential energy. Plus, initially, it was at rest, no initial velocity. Plus, final, I need to find that out. It has a mass of 5, and then Vf squared is equal to 0. So this is, I'm just going to plug this in my calculator exactly as it is on this side. I'm going to have 5 times 5 times 9.8 will give me 245. I'll keep that in my mind. And then 5 divided by 2, let me just double check that. This will give me 2.5. So this one will give me 245 plus 2.5. That will give me 245. Vf squared is equal to 0. I'm just going to take the one to the other side. 245 is equal to negative 2.5. Vf squared, divide both sides by 245. 2.5, this and this will cancel. So I'm going to have 245 divided by 2.5. It is a negative. That gives me 98. So I'm going to find Vf squared as 98. You can keep the negative there. I'm going to put both under square root. I'm going to eliminate the negative under my square root. I don't want to get an error. And this gives me 98. Let's find what the velocity will be. So this will give me this will give me 90 to 2 decimal places. This will give me 9,90 meters per second. And that is then how I would have answered this. They did say energy principle. Had they said equations of motion, or if they didn't actually say anything else, then you could have used Vf, Vi, delta T and all that stuff. But they did say energy principles. Energy, we do know, is potential energy and a kinetic energy. So that is one way I would have answered this question. Thank you so much for staying tuned with me. All the best for the rest of your exams. Stay prepared and never actually give up. And always remember, plan. I will see you next week.
What's up, peeps? Welcome to Moby School. We are here to make sure that you, yes, you get all the marks that you deserve on the go. We're here every Mondays to Fridays from 2 to 3 p.m. only on Mindset Learn TV. Now, this is a whole hour worth of revision just for you. And I hope that you've got your notepads and your pens ready, and that you and your study group are game for today's revision session. Now, my name is Joe, and just like you, I am also in Matric, and I'm here for a whole hour to make sure that I ace my final exams. And I hope that you will be doing the exact same thing. Now, do remember that we love hearing from you guys. guys. So log on to our Facebook page, which is www.facebook.com/Moby School SA. Drop us your comments, like our page, share the page, and even spread the Moby School family even bigger. Now, isn't that cool? Yep. Yes, it is. Now, do remember that you can catch us here for a whole hour of revision session where all of our awesome teachers come right here to help you guys revise. So on that note of the first revision session, let's head straight to our teacher.
Now, temperature. What is temperature? When we measure the temperature of anything, a gas, a liquid, a solid, what we are doing is we are getting some kind of measure of the average kinetic energy of the particles. Why do we say this? Well, what does the kinetic energy of a particle give us? Well, it tells us how fast particles are moving around. Now, let's ask the question, how can we make them move faster or slower? Well, we can make them move faster by putting heat energy in, because the amount of vibration and movement of particles is a measure of the amount of heat in that system, the internal energy of that system. Increase the amount of heat, you increase the amount of movement. Remove heat from the system, and you will slow the particles down. Now,